I wanted to start the meeting just quickly, and I think we're all on the same page of wanting to kept moving forward, and not introduce any unnecessary delays, but feel confident that it's going to work. And so there's probably more urgency with some people than others, but this is what Sid and Srini and myself are striving to achieve, to build up confidence among this team that we have a workable architecture and API and gRPC specs that we can move this forward. Not every detail is ironed out, and there will obviously, as we get to coding, there will be changes that likely will occur that we will expose and get feedback on. So the KEP doesn't have to be perfect; it has to be good enough that you guys have confidence, and that's the litmus test, I believe. Sid will be presenting some things. There's one part of the meeting where we're going to show you 2 alternatives and get your input on that real time. And did I forget anything, Sid?
No, I think you got it all. Just one thing is, if we do find issues, say even some even major issues after we start coding, we can always go back even to the drawing board and correct it as needed. But for now, I think it's best to focus on the larger picture. So I'll start now. So as of last week, where we left off was looking at this reference diagram of how what the relationships between different API objects in this cozy world are. So I'll quickly go over what this diagram represents. So when a user when a user wants to create a bucket, they create a bucket request object, which points to a bucket class, which has a set of properties for how this bucket should be created. And Cozy uses the combination of a bucket request and bucket class to go ahead and create a bucket in the backend. When the user wants access to that bucket, they create a bucket access request object, which points to a bucket access class for the parameters for the type of access that's needed. And the bucket access request points to a bucket request, which is in turn used to refer to the bucket itself. Cozy goes ahead and uses a bucket access request and bucket access class to create a bucket access object. Now, all the bucket access, all the users that have access to this bucket are captured in this bindings field of a bucket, which has a list of bucket accesses that have access to this bucket. So this is the architecture as we left off last week. And some questions came up about how to do deletion. And for that, I have the same diagram. However, I've added a bunch of new bucket access requests. The workflow surrounding this is like this. When a brownfield bucket access is required, that is, say a user in a different namespace wants to access the bucket, they would have to create a bucket access request object in their namespace and then point it to a bucket request in the same namespace. So an additional bucket request has to be created for a brownfield bucket in the namespace where the access is required. So we end up with multiple bucket request object pointing to the same bucket. Now comes this question of deletion. The deletion workflow, what we want it to be is the deletion of the person who creates the bucket does it through the creation of bucket request. The deletion also should be done through the bucket request. That is, the deletion of the bucket request should result in the deletion of the bucket. Now, given this, and given that we have multiple bucket requests, the deletion of which bucket request should lead to the deletion of the bucket becomes the question. And how would the user know which bucket request to delete to trigger the deletion of the bucket? This was the issue we found with the, or this was one of the unresolved parts of the design that we found after looking at the reference diagram.
So
So
this has been sorry, I was on vacation last week, and so I had to had David bring me back up to speed. Why I don't understand why we don't follow the model we followed for snapshots, where like we don't actually have multiple things pointing to the same object, but instead we just have multiple unnamespaced objects, each with a one-to-one relationship, because it solves so many problems to do it that way.
So you're saying we have bucket request be namespace, sorry, be cluster scoped.
I think it means a new bucket for every different bucket request rather than mapping.
Yeah. Just so
and
you'll end up with multiple bucket objects pointing to the same actual bucket, but then deletion becomes simple because you have a one-to-one relationship between your bucket requests and your buckets, and they all have deletion policies, and whatever one says to actually delete it causes the deletion to occur, and all the other ones don't.
Yeah. So Ben, let me take a crack at this because
give me one second. So if we did that, we would end up with multiple bucket objects pointing to the same backend bucket. Then the problem becomes deletion of the backend bucket, where multiple bucket objects. We will still have this problem. I think there's a better solution for this. So what we explored, we had a conversation about this earlier this week in the engineering meeting, was this idea of a single ownership. That is, the bucket request that creates the bucket ends up being the owner of the bucket. All the other bucket requests, the deletion of them would not trigger the deletion of the bucket, but the owner bucket request, if you deleted it, it would lead to deletion of the bucket.
So, I mean, that sort of seems intuitively like how most users would like it to work, but you'll always find someone who's like, I actually want to do it differently. And just having a deletion policy lets you decide which one will actually cause it to get deleted. Like,
any namespace should be able to delete the bucket when the whole process is done. So it's
any namespace should be able to leave I mean, they should be able to delete access to the bucket, but deleting the actual bucket should be given to namespaces that did not originally create the bucket.
Yeah, if the access is granted with delete permissions, any namespace should be able to delete the bucket when it's done.
Right. The key would be that when you set up the new bucket request to bucket binding, you would decide whether that one had the capability to delete it or not. And in theory, either the administrator who did that or the controller that did that on the user's behalf would know whether that was the right thing to do in that situation. But it puts the problem in the hands of that entity, not at the Kubernetes API level, because then the Kubernetes API becomes simple. You just say, well, if this bucket is marked as delete on the deletion policy of delete, we'll do it. And if it's not, we won't. And it's someone else's job to set that correctly so they get the behavior they want.
Yeah,
Ben, what happens when there's a conflict? Two different storage classes point to the same back end. One storage class says retain and one storage class says delete.
Then the delete will want deleted. So I think he doesn't mean retain
Is
policy.
that what we do? I mean, that's what the code does today?
So he doesn't mean retain policy. The retain policy is or release policy is for the contents of the bucket. He means the bucket itself. That is, so it won't have this this second option of retain. It'll be a boolean which will say either this one deletes the bucket or it doesn't. And
that's how snapshots work today. And so if you want to do any kind of snapshot sharing, you can clone the objects and set the reclaim or the deletion policies on the clones to retain, and then you have no fear that those guys can delete the thing. But if you want to grant ownership to some other namespace to do the ultimate deletion, you can.
That's
Just need
fair,
administrative privilege to do that, or a controller that will do that for you.
Right. That's fair. And if you want to grant privileges to any other namespace that wants to delete it, you should be able to do it, right?
Yes.
Now, what happens if multiple namespaces have deletion permissions on the same bucket? It's okay, right?
Yeah.
Well, I mean, it might be okay, right? Of course, what will happen in practice is the first one to do the deletion will actually cause a deletion, and everyone else will have a broken bucket. But like,
about that.
So if you don't want that, you would avoid setting it up that way.
Right.
But that's how snapshots already work, and PVs too, for that matter. I mean, there's nothing to stop you from creating the situation with PVs. If you want to have multiple namespaces have access to the same volume, you could do this. It's just you have to be careful.
I think Ben, it's with volume and snapshots, maybe it's a little bit different, because with volume and snapshot, this situation is very rare when you have that situation. I would say, from my experience, like, why would you have this like same volume pointing to the same multiple volumes pointing to the same underlying volume? I'm not sure.
It's relatively rare. I agree, but like the API pattern in Kubernetes works very well for that.
Sure.
Model.
But here we are talking about one of the primary use cases, and it like creating that kind of ambiguity for primary use case seems like maybe not.
Oh no, we're not suggesting.
Desirable.
We're not suggesting multiple bucket objects for the same backend bucket anymore.
That's
But
I think that is still what Ben is suggesting.
Yeah, I believe that in the absence of some better Kubernetes API mechanism for helping us do deletion properly, I don't see a way out of that. I mean, I agree that like it's awkward, and if the primary use case is to share across namespaces, it's especially awkward. But I don't know how you get deletion to work reliably.
So if we go down this route, can we just, so if we go down this route, that would also mean that we then have a one-to-one from bucket access.
Yeah, so that's what I wanted to bring up, Andrew, is two things. What you and Ben that's a great question, Ben, because that is the nature of this design and architecture. So that's a fair discussion to resolve and make sure that we have a good solution. And second point is we have a one-to-one mapping between a bucket access request and the bucket access cluster scoped object, and that shows the access to a bucket. We have a many-to-one between bucket request and the B instance, the bucket instance, and that reflects more naturally the abstraction of, the Kubernetes abstraction of the physical world. And so we are blending both in this design right now.
Right, but okay, go ahead. Sorry.
Well, I just wanted to point out that there is this one-to-one map, and if you think of brownfield, especially any kind of static brownfield, where an administrator is creating bucket instances to reflect an existing bucket, if you do one-to-one mapping, that administrator is creating a lot of bucket instances that all are basically identical.
So I think that is exactly the discussion that led us to do this multi-to-one binding. But can we test that? Because that actually, if that isn't true in practice, if the number here is finite and not overburdensome, then I would have to agree with Ben that just making every bucket access request bucket be a one-to-one, every bucket, bucket request to bucket one-to-one, everything being one-to-one. Because the whole reason for the many-to-one was this idea that an administrator would only have to provision one bucket and then multiple people could get access to it. I mean, that's fundamentally what has driven this entire approach of many-to-one.
Right.
And
testing out, yeah.
The many-to-one has had a number of issues that we've talked about: reference counting, how do you know when to delete, everything else. And I think what's happened is not that we can't come up with a technical, workable approach. It's just that people are uncomfortable for a variety of reasons with the different approaches, because they don't reflect They don't allow for certain use cases they expect, or they seem overburdensome to manage. And so I guess I'm asking us to push on the other side and say what would really be bad with a full one-to-one.
The problem would exist even with the other approach. If we have multiple bucket objects pointing to the same backend bucket, the same problem would exist, which is how do I make sure I delete, I don't end up with broken buckets.
Right, Ben, explain that. Basically, the administrator is responsible for provisioning those buckets. If they're pointing at the same back-end bucket, which can only happen in the brownfield manual provisioning, right? Greenfield, that will never happen.
Why not?
So,
if you have multiple bucket requests, multiple bucket accesses, you're saying it'll directly point to the bucket?
That's right. They each need their own bucket, which means that if you're not provisioning a new bucket, a manual provisioning of a bucket that points at the same underlying bucket is required. So it gives you a place to make that delete policy clear, right?
But
so you can
making the whole thing manual and requiring admin to be present in the workflow of creating a bucket. And
of brownfield only. Brownfield only, not greenfield.
And I would say most use cases are brownfield only.
Yeah.
The other thing is maybe manually managing the buckets, which is to say, if an admin had to delete a bucket, they'd have to know manually that there is no bucket access using that bucket at that point. I would think that is
it's all one-to-one. So you can, once it's all one-to-one, that can all be recorded in the non-namespace. You can know.
Let's say I have 100 buckets pointing to the same backend bucket. I'd have to basically peruse through 100 different buckets and then make sure that nobody's using the access, and then actually delete it.
You're presuming that no one's going to write controllers to help with these things. I don't think anyone is manually twiddling with YAML most of the time when they're interacting with Kubernetes. Usually you build higher level abstractions on top of these low level abstractions to make these kinds of things less painful.
I have to respectfully disagree with that one point. Maybe even the bigger point that we're trying to make is different, but just that one thing where most people are still struggling with YAML. Having worked with customers, I unfortunately know this part. And it's always like a simple, stupid mistake that's bringing down the whole cluster. Like they get a spelling wrong or something like that.
Well, I think if we have situations where you end up needing to have many copies of the same object in different namespaces pointing to the same thing, like controllers can help with that. And so it's not always an administrator. It's just some controller that has the appropriate privilege to do. And so I would rather see a layered approach where at the low level, it's very stupid and it just does what you tell it to do. And if you want smarts, you do that by installing a layer on top of that layer rather than trying to put all the smarts down into this low-level API. That would be my preference. Because then if someone wants to do the smarts differently, they can. Like if we encode everything into this API and we get it wrong, then no one can do it differently.
Right. That's why I think one suggestion Andrew made was good, which is we need to test this out. I think there is a lot of uncertainty around how this is going to be used, and I think it's worth actually putting it out there and testing how it goes. And that would mean we go ahead with the approach we flushed out the most right now, while keeping in mind that there's a better approach, and we'll treat this like a testing exercise. And based on what we learn, we can go back and try the other.
Guys, correct me if I'm wrong. The main problem comes with use case when we go from greenfield to brownfield, because it looks like for pure greenfield, like it's obvious that the guy who created bucket can delete bucket. For brownfield, it looks like admin creates bucket, and I think retention policy, if it has retention policy, should be always like retain, right? So nobody deletes it because it just should be there. And we are talking, the main problem is when it goes from greenfield to brownfield. So we have multiple accesses to the same bucket.
Right. In that case, you have two different bucket classes. One that was used to provision the greenfield and has in it that you have delete, and the other which is for all of the other brownfields and you have in it retain. So I don't think that if you if you do the multiple bucket approach, there's any question about who deletes or anything else. It's very straightforward. The bigger issue is that you have to manage.
We're assuming that the admin won't make mistakes at that point. We're saying they'll do it perfectly, where they will not end up with unintended buckets with deletion policy. There's also this other confusion there of, if I have the first, I create two bucket objects, let's say. The first, both of them point to the same backend bucket, and the first one says retain the data after you delete this object. The other one says delete the data after you delete this object. How do you resolve that?
Right.
As part of the bucket access request, or as
part of the bucket itself? Yeah.
As part of the permissions that you put on the bucket for the
it's
user
part
access.
of the bucket policy. It's the reclaim policy.
Can I add something, Sid? It's Guy. I mean we discussed this this week.
Yeah.
Okay. So I think the suggestion here is basically, as far as I understand, is to discard, so that there will be no lifecycle management in Cozy at all. And basically what we're saying is we are only managing access, right? And we have an automation saying, well, I want to do something when this access drops, right? Because like you said, if we have different policies on the bucket that we want to apply, like deleting the data at the end, not deleting, setting any permissions or whatever for the rest of the world, things like that, who is the bucket to be representing the actual thing outside? Of course, there is sharing with the rest of the world, but in this case, what we're saying is that we're not even giving a single view for all the namespaces, right? We have this like disconnected views of the bucket between them. So I think it's fine, but then I think what we're saying is that we don't want to automate bucket lifecycle things. We just want to allow provisioning and deletion.
I don't think that's true, because there's a difference between brownfield and greenfield. So for greenfield, we absolutely completely automate bucket provisioning and lifecycle. But what we're just saying is that for the brownfield case, there are a number of sticky edges. And one possible approach for brownfield is to just say, look, you got to directly deal with all those sticky edges. We're not going to try to be magic and intuit some sort of policy out of this by forcing everybody to one channel.
But then why do you need two objects in the namespace to represent that? Just, I'm not saying it's wrong. I'm just saying it does restrict what the API.
Two objects in the namespace is because they're dealing with two different problems. So one of them is whether you are pointing at an existing bucket, underlying bucket, or whether you're minting an underlying bucket. That problem is completely distinct from providing access to your user or your application to access that bucket. They're two different questions. One is bucket provisioning and lifecycle. The other is bucket access provisioning and lifecycle. And both are reasonable problems. The first has a share brownfield kind of mode. The second has a indirect mode where you've sort of handled it out of band. So they both have modes to allow for management outside the Kubernetes space, but they are different problems. You're managing different things, which is why there's two namespace objects.
Right.
I actually don't follow here, to be honest. So what are we saying right now? Is there a problem with having multiple bucket requests pointing to a single bucket?
Yeah,
there is a problem with multiple bucket requests pointing to the single bucket. The problem is it is not easy to express how you should manage lifecycle in that case. That problem exists in two ways. It exists with bucket requests, multiple bucket requests tied to the same bucket, and it exists with multiple bucket accesses tied to the same bucket. So you have effectively kind of two sets of references that you have to figure out when you can actually take action on the underlying bucket is problem one, and problem two is which of these bucket requests kind of own the management of that, because they could come in from different classes, so they could have different policies at their level. Yet normally we reflect that policy at the bucket level, not in the bucket request level. So this now gets us into a situation where
so wait a minute. I think I follow what you're saying. So the first problem is, so the bucket access and the bucket lifecycle, like you said, are entirely different. Now, we don't need to do any automated management, at least to begin with. The lifecycle does not need to be managed by Cozy, and the bucket deletion can always be manual. And we can go back to one of the suggestions that Ben made, which is have the policy on the bucket request, which when provisioning the bucket request or when creating that, you could say, I want delete permissions on this bucket request. That is, if I delete this bucket request, the underlying bucket should be deleted. That's one way of doing it. I think this style of doing things leaves us still flexible enough to try different experiments.
I guess my point is that I don't think you've actually reduced the work when you have a heterogeneous set of delete policies among the clients of a bucket.
Yeah,
One case you have to create multiple buckets, and the other case you have to go into that bucket and manage per bucket request policy statements about who's allowed to do what. So it's still a cardinality n problem.
That's an easily solvable problem, is what I'm saying. We could just as easily say only the owning bucket request gets to delete the bucket, or any of the bucket requests gets to delete the bucket, but then we wait for all the bucket requests to be deleted before the actual bucket is deleted.
Right, but owning only makes sense in a greenfield case. Right? For brownfield, there's no owner, because, I mean, you have a weird edge, which is this green promoted to brown, but I question whether that's ever actually going to happen.
Right.
I think you're likely to have pure brown or pure green. Mm-hmm. And if you look at those two scenarios, pure brown, nobody's going to be deleting it. There is no owner. Right?
It's the backend bucket, you mean? Yes. Right. The backend bucket, yes, nobody's going to be deleting. But the bucket object can be deleted. You see, that's where I think we both see the difference, which is the bucket object deletion is okay. And that's all we're going to be doing. The owner still makes sense when that's how you look at it. And the thing is, we've thought about this, and we also have an alternative approach that I want to propose, that just so we have more information about where this is going. So Guy and Jeff also brought up a very interesting approach, which is we don't have multiple requests per bucket. Rather, it might make more sense. Same diagram without the multiple bucket access requests. What we're saying is have the bucket access request directly point to the bucket and have only one bucket request.
Yeah, what this is saying is that BRs, their only purpose is greenfield bucket provisioning.
Mm-hmm. Or brownfield bucket provisioning. Their only purpose is provisioning the bucket.
But
when I say brownfield bucket provisioning, like creating the bucket object for brownfield and well, I guess you're saying the admin would create the bucket object. Yeah, you're right. You could say it's greenfield, sure.
So it is what Ben and it is this one-to-one mapping between a BR and a B, mm-hmm. But there's still only one B. But you get multiple accessors to the B, and that's where the BAR to BA mapping comes in, and that's one-to-one. And so what all you're saying is that if you look at brownfield, why should I have to create a BR and a BAR as a user? I just want access to an existing bucket, and whether it and the access is a BAR, and I don't need a BR anymore. And so what we're trying to make, this thought at least, is motivated by making the usability simpler for the brownfield user.
All right. So this definitely, I think, simplifies one case. Let me test you on another.
Okay.
If we already know one problem. Maybe we'll describe it first in case it's the same.
No, I mean it's obvious from the diagram. But the question that I'm asking is, how are you going to express your YAML for a greenfield case?
Exactly. So exactly the issue. So to explain that a little bit more, if you have brownfield access, you know the name of the bucket name of the bucket up front. However, if it's greenfield, you don't know the name of the bucket up front because you only have the bucket request and you have the bucket access request, but the actual bucket hasn't been done yet. Absolutely true. For this, so the two approaches we have, and which is where we need your help, is what we're thinking is we have the bucket access request pointing to the bucket name if it's brownfield, or bucket request name if it's greenfield. This introduces a difference in UX, user experience, for greenfield versus brownfield. And I think maybe Guy or Jeff, who came up with this idea, if you'd like to say a few things about what we how we came up with this, please.
I can just give the rationale. I think compared to what Ben suggested, I think Ben suggests that we sort of allow every namespace to be a manager, essentially, of the life cycle, right? So we extend bucket requests to every namespace, basically, right? So it's possible. We're not saying it has to be. And in our case, what we're saying is we actually restricted it to only the cluster scope buckets for brownfield, right? Which administrators sort of have to, or operators needs to manage, or the greenfield case. And I think what we said here was that we just, I don't remember if we had two options, but I do remember we had one option which will be to have like one optional field for a bucket request name, and then the controller will actually fill up the bucket name for the greenfield case, right?
Yeah. So I would just observe that this achieves the same, which is it gives us one-to-one binding between bucket request and bucket. So it actually does, for that part of the architecture, more align with the sort of Kubernetes approach. Bucket access has also one-to-one, and so then the only thing that's left is this weirdness of bucket having no knowledge of bucket accesses.
Right. We've thought about that too. So we actually don't need the bindings if this is how it looks. What we do instead is have a finalizer added for each bucket access request that gets tied to a bucket. So only when all the finalizers are gone can we delete the bucket. It's only relevant. This whole bindings concept is only relevant because we want to know if we can delete the bucket based on the fact that nobody's using it. So by using finalizers, we circumvent. I mean, it's not really not.
I'm a whole lot more comfortable with finalizers than a list of bindings, I have to say.
Yeah, I think we were talking about one more disadvantage of this model, right? Is that users need beforehand know if it's a greenfield or brownfield, if it's an existing bucket or if it's auto-created bucket. So and actually, application deployment YAML should actually really be different for these two cases. So we lose somewhat portability of this in this case.
Right. I mean, that's well said. That is the disadvantage. We have added a distinction between green and brown that a user that wants to do both, the green to brown, has to be aware of.
Yeah.
And the cost of that was to, in our view at least, potentially make the user experience better for brownfield.
I don't see a problem with that.
Yeah.
Yeah, I'm actually okay with this too. I think this is this feels good.
How common is it going to be that the user is going to know ahead of time that they want greenfield or brownfield, and if they move that application around, is that going to change?
I can't think of an instance where you wouldn't know ahead of time.
I agree. Yeah. I agree. I mean, greenfield is, I don't really care. I'm not going to be sharing this. I'm going to mint a magic name. Brownfield is, I'm going to be coordinating through this with other people, or else I'm starting with a provision set. So I think the time you're crafting the YAML, you're usually going to know.
Andrew, it's interesting.
to
I
add
thought of this sort of the first time on a couple of your comments. You're kind of making Greenfield seem like block access, right? It's just my bucket. And
Yeah.
and Brownfield more related to kind of like file sharing access.
Yeah, I think that's if you just think about as an application, why would I want Greenfield? I mean, it causes all kinds of problems, right? It's like it's non-deterministic bucket name. So there are probably a class of things where, hey man, I just need storage and I'm the only one who's ever going to use it. And then yeah, it is kind of like block, except that it's object, right? You're the only one who's going to be interacting with it. But I think it's a very different use case when you're using object for the purpose of interacting with other applications for, data processing pipelines or anything else where somebody's going to be consuming it. Yeah,
I agree with that. It's more like, or it's almost entirely just going to be brownfield. It feels like from everything I've seen too, people know the bucket up front.
But at the same time, user may think as Andrew mentioned, I need storage, and basically I don't care if it's storage like existing or a new one. I just need some storage and I'm going to use it. And it was up to admin to tell you which storage to use, and now it's more like going to user. So user needs to say, oh, I need this type of storage. It's not admin decision anymore. It's more like up to user to actually say.
I think that sums it up, right? Because when you have a request, when you just want when you want the storage, the admin can come up and match you with, or an operator for the admin would do that for you, right? And match your request with a storage, even existing one or new one. It can be different reaction to your request, right? And I think what we're saying is that when you are requesting access to an existing bucket, so in I think most cases you just have to know that, right? You know that you're not really allocating the bucket yourself.
The interesting problem here, I think, is not that you know that it's an existing bucket. The problem is that you know which existing bucket.
Right. I think that's a good point, because in many cases, what I would want the application is to request is I would like to request let's say a logs bucket, right? And I would like the admin to decide what is the logging operation policy for that. How do I provision logs buckets? Do I provision this all in the same one, or what?
Yeah.
So I may have missed something, but are we saying that minting a bucket that is going to be for brownfield, we don't have a case for that? So, because if you're minting a greenfield, it's going to be a non-deterministic name, right? So you're not going to be able to have an automated way of making that brownfield in the future.
Well, it's non-deterministic, but once it has been created, you know what it is. So if a greenfield app has written into a bucket and created a bucket, and then at a later point in time, you want other apps to be able to access it, then you would just provision the brownfield pointing at that specific bucket.
But would I be able to automate that?
Well, the problem with automating it is that then it's an order of operation thing. Which guy's going to create the bucket? If you bring the other guys up that want access to it before the bucket is before the greenfield bucket is created, then you kind of are locking yourself into a deployment model. So if
it's not only you need to know the name of the bucket to the bucket object in the Kubernetes, and that name may be actually dynamically generated potentially. Maybe it's stable, maybe it's not, and it's also it's kind of knowledge you may not have at the time of the deployment.
So where the name matters the most, I think, is this green to brown. Like, why did I provision a bucket if I'm not going to access it, right? So I've got an app. It needs a block mode type access to a bucket, and it needs to provision the bucket and then use the bucket. So in that case, it somehow needs to know the name of the bucket instance that we've created for, and that name has randomness in it. So how does it know? It's not a deterministic name like it's been mentioned. So that is what Sid mentioned a few minutes back, is that in that case of green going to brown, which is not rare, it's every greenfield case is a green to brown because I need to access the bucket. And therefore, what you would do in your BAR is you would reference the name of your BR. And in the BR, we know the B. So you're still good. You don't need to know the name of the bucket to create the BR or the BAR. Neither one needs to know the name of the bucket instance.
Well, knowing the cluster scoped bucket is effectively knowing. I mean, but I have a thought here, because this is actually how the original proposal worked. What if instead of listing the bucket name in the BAR, what if the bucket access class did that?
Yeah,
because
we actually
then you could do this. Then you're not locking yourself into a particular bucket, but an access class could be locked to a particular bucket.
Right. And Andrew, I don't know if you remember the old library design we had years ago. That's what we did. In the
Yeah,
class.
yeah, that's what that's you know.
And yeah, we could do the matching like PVC, where based on the bucket access class parameters.
No, I'm not. I'm actually suggesting it's more than that. When you're doing a bucket access class, you know, in other words, instead of the bucket access request having to know that it's greenfield or brownfield, we make the bucket access class know whether it's greenfield or brownfield.
Right.
And so it's the one that contains the reference to the bucket or to, yeah.
And we did that in the old library design to unburden the user from having to know the name of the bucket.
I think if we do this, I think the concept that Ben raised, having just a straight bucket request and the bucket, it makes a little bit more sense actually, because if what we are saying is that give the admin to just control sharing, and not only control but be responsible to do everything about it or automate it on its own, but Cozy is not part of it, then it makes more sense to just have it like bucket request and the bucket represent a single namespace sort of management, and not because just having another role for the access class to represent exactly which bucket, right? It suddenly becomes some more, and a class suddenly becomes something we instantiate in normal workflows, which sounds weird.
Yeah, also, yeah, it is weird. That is true. So I think what I want to do now is I think we should I think we should test it out. I think we should test out and see what the users are going to use, how the users are going to use this. Basically, I want to know, out of these two approaches, which one should I try first? My preference is the second approach, where we have the BAR point to the bucket, because I believe once we start putting it out there and getting feedback, I think we'll see even more problems, or we'll see solutions that we couldn't possibly think of right now. And so that's what I need some input on, which is based on the consensus here, what do you all suggest should be the first experiment? Shouldn't be this one?
I think I like Andrew's a little bit modified approach, where bucket name is in the bucket access class. It becomes differentiator between green and brown field, whereas bucket class is always a green field. It sounds like a good alternative, I think.
Yeah.
So
I like it too. I like it from the point of view of you unburden the developer from the brownfield case, from needing to know in the user space what the name of the bucket instance is, and I like that part. A downside potentially is that you need right now the BAC is an abstraction of policy, right? To well, it could be to a group of buckets. It didn't have to be. It's not tied to a single one. With putting the name the B dot name in the bucket access class. We've now, for brownfield, we need a BAC for every bucket, right?
Yeah, I think that opens up a can of worms, to be honest. I mean, I'm not opposed to trying it out, but maybe we should flush it out more if you're going to go down that path. I think.
So
yeah, go ahead.
yeah, let me just say that it strikes me the difference here is between accepting this wart of having to provision bucket access classes. Note that it's one per bucket, not one per access, right?
Correct.
So it's basically one per brownfield bucket that you're trying to provision. So it's not quite as nasty as the other approach, which was lots and lots of buckets. So that mapping, which granted what you just said to the fact that we're sort of blurring now two concepts together, has to be balanced against the fact that if you're listing bucket name, you effectively either make that bucket name have to be like a class and not actually have any connection to your underlying infrastructure, or you make the workload completely non-portable.
Yeah.
And the reason I'm so pushing that is
I agree, by the way.
Yeah,
I agree now. I think there has to be a mapping before we point directly to a bucket name. I agree with that. Yeah.
Andrew, what did you mean by lots and lots of buckets?
Right. So what you introduced earlier that I was arguing with you with, I'm not I tend to do this trying to explain other people's ideas. I apologize for that. But what I understood was that you were suggesting that, look, let's just have a bucket, one-to-one bucket at request a bucket, whether it's greenfield or brownfield.
Right, but crucially, that's one like per namespace. So like if you have a bunch of stuff all in one namespace, you still only have one bucket, one bucket request. And I think it won't be super common to go across namespaces with this stuff. And
I'm not sure that's true for brownfield, but regardless, just to distinguish between the two, it would mean that effectively the difference is a bucket per user of the bucket, where user is namespace, or a bucket per underlying bucket, but both approaches being able to preserve the one request to one bucket. So the thing we've been talking about lately preserves the one request to one bucket. It just introduces the fact that you've got to have one class per brownfield bucket. So that's the downside of that one. But of all of the things we've talked about here, this feels like the one that is the least objectionable.
Yeah, but also there is a question how it's going to work with greenfield, with this bucket access request. How does it know the bucket request to point to?
Yeah, so that's a great question, which is if a bucket access request is depending on a bucket that is greenfield, how is that expressed in the bucket access class?
The bucket access class is driven by the admin.
So but what it could we could still have the bucket access request have an optional pointer to a bucket request.
Yeah, we're coming back to where we were earlier.
Yeah, that's what we were thinking.
Well, not so much coming back to, but using a part of your earlier and mapping and adding the bucket access class thing. A hybrid of
when the bucket,
instead of the bucket directly. I mean, I think what we're right now trying to discern between is a tiny detail, whether, and I call it that deliberately, which is whether the bucket access request directly points to a bucket from the original, from the design that we explained, or if it points to the bucket through the bucket access class. I think that can be resolved. So we only have very little time left. So I think that can be resolved going forward. I want to quickly summarize all the things we discussed throughout this care preview in the last 4 weeks and the changes that I've just summarized here. And I want to first, go through this, which is, so we, these are the list of changes that we brought about based on the discussions here. If I've missed any, I'm happy to add them. But what I have here are, one was we made the access policy opaque instead of trying to model allow and deny rules. We had this problem come up with service accounts where if there was a conflict of access for the same service account, how do we resolve it? We resolved it by, we came up with the conclusion that it's best to deny any new access requests that have a policy that's different from what was originally given. The third one was a bucket credentials path resolution. We weren't entirely sure of where we were going to mount or provide the credentials within the pod. We resolved it by saying there should be some sort of a base path, and there should be the file name or the rest of the path of where the credentials should be given. So for instance, if you're running an Ubuntu pod, the home directory might be different from running a different pod with a different OS. So that should be left to the creator of the pod, is what we decided. The final thing was we changed from phase to Boolean conditions. It wasn't really a major change, but it was there. If I've missed any, please let me know. But I wanted to kind of give you a high level picture of all the changes we've done, and I think we should talk about next steps in terms of I think after today's discussion, I think the decision we're going to end up with is some form of this design where we either directly point to a bucket from bucket access request, or point to the bucket through the bucket access class. And in greenfield cases, we have the bucket access request likely point to the bucket request. So given this, what would you suggest are the next steps, Saad?
I think this was the last big open issue in terms of kind of data flow. Once we have this locked down, I think it would be okay to sign off on working on the alpha, and we can take it from there. So maybe let's continue this discussion next week. I think one more area, and it's pretty minor, that I wanted to talk about was we have protocols S3, AWS, GCS, etc. Small minor nit. Do we need a version number on that? Is that going to be important at all? A specific version of the S3 protocol, for example.
Yeah, so S3 has deprecated S3V. So there's S3V2 and S3V4. Weirdly, there's no S3V3. And S3...
the API version. There's a date API version, right?
Yeah. S3V2 is being deprecated, and I think we should just go with S3V4.
Not signature version. API version is a more complex, releasing dates. That it's like a string. It's a date string that a client of the SDK can specify that I require this and that API version, and then the server can reject or whatever.
You mean based on the tag, right? Based on the version number, the authentication model changes.
No. So I mean, just as a generic API version for the entire API. It's like for the protocol. The entire protocol, not specific to an object or...
Right. That's what I'm saying. S3V2 and S3V4 are for the protocol.
Yeah, but even if it's S3V4, like there's no guarantee there won't be a V5 someday. Like,
yeah, what I'm proposing here is basically, right now we let the client pick a protocol. We should also let them specify the version that they expect.
I think we already do. We have that field. We have protocol signature. What do we call it, Jeff?
Well, it's protocol signature, but I don't know if that meets the requirement that Saad's bringing up. It's a good point, Saad.
So the way I've modeled it in the API is the signature is either S3V2 or S3V4.
Sorry, can you show me how that works?
Yeah.
It says in the KEP protocol signature, this is in the bucket instance, specifies the protocol targeted by this bucket instance.
I just sent you a link on chat to see. I mean, the example that I thought that Saad meant was an API version that you're locking into API versions, not signature versions in the sense that does the protocol, how does the protocol work technically, but what is the semantic versioning of the API,
Is
right?
this what you meant, Sad?
Yeah, I mean, as far as I'm concerned, if I have a application that I'm shipping with a certain client,
Uh-huh.
that client is going to be able to be compatible with some subset of protocol versions. How do I, as a application developer, advertise this is the subset of versions that I support?
Yes. Yeah.
The bucket creation does not restrict the version. So, for instance, if a user requests for a bucket, regardless of the best they can do is tell us what version of the S3 API to use
Right.
to do the creation.
That's what all clients do, right? You even compile this into the client. As you see here, like this is the client code who actually has this, stamped inside the code saying this is how the code works. It cannot work differently, right?
So
So
this
you
would
stamp
be,
it as well to the deployment to match and verify with your protocol, server that it matches.
yeah.
That's
I think that can be easily accommodated. Yeah, either we do something like some gRPC API which compares what's given by the user to what's possible by the provisioner. That would mean we need to add
it's in the access, right? It's in
yeah,
bucket access only, right?
Yes. And when the provisioner registers with the kubelet, it can say what versions it supports, right?
I
right.
mean, the only reason that we care about this is if how we surface the information, bucket information into the container changes by version, all right? Otherwise, for us, it's effectively passed through. We don't really care what the version is. If it's S3, depending on the protocol, we change how we surface up the information into the container.
Right, it's passed through. Yeah.
And so then the question is, would it change from version to version in terms of how we surface up into the container? I think going back to what Ben said, it may not be the case today, but it's possible in the future. There's two ways of handling that. One is you have an explicit field for a version in addition to protocol. So you say protocol name and protocol version, or you concatenate those two into the name. And so instead of just, S3, you could say S3v2 or S3v4 or whatever.
That was
Right.
my original idea. Yeah.
I think that's fine. We just need to kind of write
Document
that out and
yeah.
agree on it and make sure everybody's okay with that.
Right. Yeah.
That might be more flexible, building it into the name, like S3v4, because then some of the fields under there may be different, right? In that structure.
Yeah,
yeah.
The problem is if S3v5 comes out and it doesn't change, now you have this weird semantic where you're like, well, it was backwards compatible, but all my stuff says S3v4, and I don't know if it's going to work with v5 because it's part of the name, and it looks like a totally separate protocol.
If we're
Oh, I see what you mean. Yeah. Yeah, and then we'd have to do parsing and to check. Yeah. Maybe given that, might make sense to have two different fields.
Yeah, it's a good point.
Like a protocol family and protocol version. Yeah, I think this is a good discussion. I think yeah, it's very it's tough to decide between the two approaches we kind of shared here, and once we figure that out, I think we'll be clearer.
Okay, let's carry on the discussion at the next meeting. I think we're getting close.
So please join us on Monday at 11. We have these discussions, or at least parts of them, on Monday at 11. It's an engineering meeting, but it still happens. So it would be great if all of you joined.
Yeah.
I think I can join on Monday. I'll try.
That would be great. Everyone's invited. This is the same link, isn't it, Sid?
Yeah.
It would be great to get more. I mean, I think I see the finish line in front of us, so we're really close. If we can just keep the momentum up another week, I think we're going to get there.
Yeah, Monday meeting will be good.
Did you say it's the same Zoom?
It's the same Zoom, yes. 6
Okay.
storage Zoom, yeah.
And then we're 4 minutes late. So can we wrap up now? Is that all right, Sid?
Yeah, I'm done.
Thanks, everybody. Really appreciate it. This was a constructive dialogue.
All right. Thank you. Take care.
Thank you.